Bismillahirrahmanirrahim. I am Kanjaf from class 2B1, and today I have come to explain about the theory of antibiotic resistance. So, what are antibiotics? Antibiotics fight bacterial infections. So, bacterial infections can be reduced by antibiotics, but the overuse of antibiotics isn't good. The overuse of antibiotics then causes or teaches the bacteria to resist against them. For example, over here, I have made these. I've put inside the bottle. I've put beads looking like bacteria because we don't know what bacteria looks like, but something like these I've kept inside. And on top of it, I want to show you what happens. So usually when we use antibiotics for the bacterial infection we have, it's washed away by the antibiotics, but not for long. When we overuse antibiotics, then the bacteria learn how to resist against it. As they learn how to resist against it, then, like for example over here, I'm going to put the antibiotics inside this. As we can see, it's not passing through and going to the bacteria because I have kept a net here. Now the net is replacing. It's like the antibiotic resistance. It's not letting the antibiotics wash away the bacteria. So, is this a natural selection? Yes, it is. It is natural selection. Because if you're using antibiotics, some bacteria will resist and defeat the antibiotics. The surrounding bacteria will multiply and pass on the genes of antibiotic resistance to the offspring. The population of resisting bacteria will increase, means the fit, and the antibiotics will fade, means the weak. Thank you.
Doesn't have much power.
Why don't you?
Assalamu alaikum. My name is Aliaskar Naushad Manji.
My name is Ali Muhammad Reza Merali.
My name is Uthman Kasam. Today we are going to be demonstrating a project about lungs. We are going to be seeing how the lungs expand and relax when we breathe air in
And out. Okay, now let us talk about the materials we have used on this. We have used the two balloons as lungs to identify when they expand and when they relax, and we have used straws. If you can see, we have used straws to connect the lungs and also to breathe into it, so we can keep the air in and out to show how does it expand and how does it relax.
Then we used some cardboard to make the body, and we covered it with some vanilla.
We used scissors to cut the cardboard and the straws, and we used ruler to measure the length of the straws.
We also used some tape and some glue to just stick things around. We shall now begin with the project, with the demonstration, and Alyaska is going to blow into the straw and then we're going to see what happens.
So as you can see, the lungs expand.
Now, let's look at the science behind this. As we human beings breathe in air, our lungs tend to expand. They do expand, and as we breathe out air, they stop expanding. So as Alesco showed right now, as he breathed in oxygen, it started to expand, and as he stopped to breathe into it, it started to relax and went back to the original shape. So that is our demonstration. I hope you guys have learned something. Thank you.
Blow it again.
Assalamu alaikum. So as a science project, we have decided to make a torch. Every one of us, we have decided to contribute a little to make the torch.
The materials used are a bulb, one pair of battery, each 1.5 volts, which is inside, a plastic pipe, copper wires which are inside, super glue, a switch, duct tape, and bottle cap.
Steps taken in making: join two 1.5 volt batteries with duct tape. Connect the bulb with copper wire. Connect one end of the terminal to a switch and connect the other terminal to a battery. Insert the whole thing in a pipe to make the torch light like a structure.
Science behind it. There is flow of electricity through the wires from a battery to a bulb. This is a conversion of electricity to light energy.
So, how to use it? To make it work, you have to on the switch at the bottom to make it on. And if you want to turn it off, you have to turn the switch off.
Assalamualaikum everyone, our group made a torch. The materials that were needed to make the torch were two 1.5 volt batteries, two copper wires, a switch, a bulb, and cellophane.
How to make it. Join two 1.5 volt batteries together vertically. Stick one end of a copper wire to one end of the batteries and one end to the switch. Take another copper wire and stick one end to the switch and one to the bulb. Last is to stick the bulb onto the other end of the batteries.
The science behind it is the cells or battery pass on electric current through the wires to the bulb, which heats up the bulb's filaments and causes the bulb to glow or light up.
How does it work? It is an idea taken from the series circuit, but the components are arranged in such a way that it can be used as a torch. When the switch is turned on, the two copper wires are connected and the current flows to the torch, lighting up the bulb.
Good morning. My team and I, we have made a baking soda rocket. We have used multiple materials in this rocket. One of them is a 1 liter water bottle. Another one is vinegar, which is in the bottle right now. Another one is soda bicarbonate and wooden sticks to support the bottle and sellotape to stick the sticks to the bottle.
The procedures that will be followed to do this experiment will be adding baking soda to the bottle vinegar and then turning the bottle upside down to the stand supporting it.
The science behind it is that the pressure builds up due to the vinegar and the baking soda reaction. When it builds up pressure, the cork stops the pressure from escaping, thrusting the bottle up.
When the pressure is too great, the cork comes out. Because of the pressure, the bottle will launch and thrust into the air, or in other words,
The downward force of the cork being forced out of the bottle creates an upward thrust force, which makes the bottle shoot up into the air. This is an example of Newton's third law of motion. For every action, there's an equal and opposite reaction.
Epic.
Because I have too much baking soda. Because I have too much baking soda.
No, the cork was not tight enough.
And
You weren't
someone added too much baking
fast
soda.
enough, man.
Assalamu alaikum and a very good morning to you all. Today, my name is Abdali Maka.
And my name is Maya Kubai.
Today we are here to demonstrate about wind energy.
So the materials we use are a jar for the motor to stay in, a CD for less air resistance, and some bottle caps for the wind to capture, and a voltmeter to measure voltage. I will show you that it supplies energy. As you can see, so there is energy being supplied.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. We have tried to make a model which is talking about wireless power supply. As you can see with your naked eyes that you can see a battery connector, you can see an LED light and two coiled copper wires. And other things are hidden down from the transistor and the resistor. So this model works without any connection in the middle of the coil. So this model briefly also shows or elaborates how wireless power is currently used in next generation smartphones, battery charging, and to be very soon used in other usages as well. Materials used in this 27K resistor, a transistor which is 2N2222A, a 9-volt battery, an LED light, insulated copper wires, battery connector, cardboard, some tapes and glue. How we made it? Two coils are essential for the setup, which are this and this. The first coil, which is the receiver, is made up of about 30 turns with only two ends, which is connected to the LED light. It is this one. It is made up of 30 turns with only two ends, and it is connected to the LED light. And the second coil, which is a transmitter, is made up of an extra third end that is created as a 15-turn or loop. The coil connects the resistor, and the battery. So now we are going to show you. If you take this and connect it here, the LED will light up. Without even if you see there is no wire here, even if I keep a cardboard in the middle and try to on, it will on, wireless. So now, how does this work? The resistor and the transistor converts the DC power from the battery into AC power. This resistor and the transistor convert this DC power, which is the battery, into AC, which gets into this coil and induces into the second coil. Why it gets
Something fun.
As you can see here, this is called a homemade air cooler. The things that I use here is a DC motor, a propeller which is a blade, a 9-volt battery with its connector, and a switch with wire. So what I made here is that I connected the motor with the propeller, which is the blade, and I used a hot glue gun so I can stick it. Then I took the top of the container, keep some holes so I can take out the wires. Then I connected with the switch over here. The switch which is connected with the battery and a connector goes to the motor. So when I on here, the fan moves. And there is a hole which I made over here, keeping some ice, and so that the air comes out over here. As you can see here, there is a small air coming down. It's not exactly an AC, but a small air cooler. So if you keep some ice, there will be some cold air.
are presenting my science project which I made with a water dispenser. And basically, today the features featuring inside is the overview and materials used, then the science behind it, the advantages and disadvantages of it, the mechanism, and the bibliographic references. So the overview materials that we use is a 500 ml bottle, a straw, some cardboard box, paper, glue, and marker were assembled. Then we pierced a small hole at this side to fit in the straw, and we stuck it well. An opening was made in the box to fit the bottle and cover it. A clean sheet of paper was glued onto the cover to give it a polished presentation so that it can be clean. Then a water drop image was cut on and colored in and glued as a label of the dispenser. The wordings attached were printed to mean the thirst, denoting that the dispenser is used to serve water and quench thirst of those who are thirsty. Finally, this thesis was prepared and printed. And the science behind it is the cap of the water dispenser allows gravity and vacuum pressure to do the job of filling a glass when someone uses the water spigot. When this happens, air is allowed into the bottle so the water can escape into your glass or bottle. So we open the cap and the water will start spilling. And once we are satisfied, we just need to close the cap and the water will stop. The advantages and disadvantages of a Once we are satisfied, we just need to close the cap and the water will stop. The advantages and disadvantages of a water dispenser. We'll begin with the benefits. So, the benefits is that you get clean water. You have the option of loading a bottle of clean, purified water on the water dispenser and make it easier for you and your family to access clean water wherever they want because it's small and portable. It's easy to use. Simply press the spigot, open the bottle cap and voila, quench your thirst.
Voila.
Safety. The simplicity of its usage makes it child-friendly and poses no harm to the inquisitive of kids who would like to use it. Easy maintenance, cost-effective, promotes recycling. Then we come to the disadvantages. There aren't many disadvantages of making such a dispenser. However, we need to be careful of a few things. It is easy to catch dust. When such dispensers catch dust, they easily become a breeding ground for bacteria and other diseases. While as quality, you have to check the quality of plastic before you make the purchase or make one for yourself. Because if you refill old water bottles, you might be causing more harm than good. Plastic, which is the main one because of burnings and all. So the main materials are the plastic bottles and the straw, both of which are neither eco-friendly nor are they biodegradable. Then we have the mechanism. The water is placed into the bottle where there's a small hole where the mouth of the bottle fits. It is designed like this so gravity and vacuum pressure will fill the machine with water from the bottom and then it gets released into the glass switch. The faucet or spigot is triggered / pressed or open. In some type of dispensers like this one, a
A regular bottle is used and is locked upside down, but still requires pressure to let the water out, opening and closing the valve.